Federated systems are becoming the norm. Different organizations, different infrastructures, different security models, all working together. On paper, federation sounds efficient. Shared data, shared services, shared trust. In reality, federation multiplies complexity. And complexity is where security fails. Traditional security models assume a single organization. One hierarchy, one policy framework, one identity authority. One chain of command. Federated environments break that assumption. Now you have multiple authorities, multiple policies, multiple risk appetites, and sometimes competing legal obligations. Security design becomes political as well as technical. The first major problem in federated systems is misplaced trust. When organizations connect systems, they often assume the other side enforces similar controls. That assumption is rarely tested deeply. Access is granted. Data flows begin. Integration accelerates. Only later does anyone ask whether the security posture is truly aligned. Trust is declared before it is verified. Another common failure is unclear ownership. When something goes wrong in a federated environment, who is responsible? The data owner, the platform operator, the identity provider, the integrator? If responsibility is not explicit in the architecture, incident response becomes negotiation instead of action. Attackers move faster than committees. Identity becomes central in federated systems. But federation often introduces identity sprawl. Multiple identity providers, multiple token formats, multiple trust anchors. If identity federation is not tightly scoped, access spreads further than intended. We have seen environments where federated identity allowed users from one organization to access systems that were never meant to be exposed externally. Not because of a breach, because of overly broad trust relationships. Then there is the issue of transitive trust. Organization A trusts Organization B. Organization B trusts Organization C. Suddenly, Organization A indirectly trusts Organization C, often without realizing it. Transitive trust is rarely mapped explicitly, but attackers understand it very well. They look for the weakest participant in the federation. Compromise there becomes a stepping stone. Data classification also becomes harder. Inside a single organization, classification frameworks are usually consistent. In federated systems, classifications differ. One organization's internal data may be another organization's restricted data. Without alignment, data can silently cross boundaries it was never meant to cross. This is not always malicious. Often it is architectural drift. Monitoring is another weak point. Logs are distributed. Controls are distributed. Visibility is fragmented. Each organization sees only part of the picture. Attack patterns that look harmless in isolation become obvious only when viewed as a whole. If monitoring is not coordinated, detection becomes blind at the federation boundary. Legal and jurisdictional differences add another layer. Data sharing agreements exist on paper. Operational realities evolve faster. Regulatory requirements may conflict. In some cases, legal constraints limit how much visibility or control one party can have over another. Security architecture must reflect that reality, not ignore it. So what works in federated environments? First, explicit trust boundaries. Trust should be narrow and documented, not assumed. Access should be scoped to specific services, specific datasets, and specific roles. Broad trust relationships create broad risk. Second, minimal transitive trust. Trust does not automatically extend beyond its original scope. If Organization A trusts B, that does not mean A trusts everyone, B trusts. Architectures must enforce that separation technically, not just contractually. Third, strong identity governance. Federated identity should not mean uncontrolled identity. Attribute validation matters. Lifecycle management matters. Revocation must propagate quickly across all connected systems. If a user loses access in one organization, that change must reflect everywhere it matters. Fourth, shared incident response models. Federation without coordinated incident response is fragile. Roles and escalation paths must be defined before incidents happen, not during. Time lost clarifying responsibility is time attackers use to expand access. Fifth, Designing for containment. Assume that one participant in the Federation will eventually be compromised. The goal is not to prevent all compromise. The goal is to prevent compromise from spreading across the entire Federation. Segmentation, least privilege, and strict interface contracts become critical. Federated systems are powerful. They enable collaboration at scale. They enable shared infrastructure across countries, industries, and sectors. But they also expand the attack surface dramatically. Security in federated environments is not about adding more tools. It is about controlling trust, controlling identity, controlling propagation of failure. If those controls are weak, Federation becomes a multiplier for risk. If those controls are strong, Federation becomes resilient. If this topic is relevant to your organization, you can follow the channel. We publish one in-depth video each week focused on real-world cybersecurity architecture and long-term system design.